What's up, YouTube? Professor McCullough here, because, who else would it be? I mean, you obviously clicked on my channel to watch this video that's hosted by me, so who else would it be here? So I don't even know why I even say Professor McCullough here, because obviously I'm here. I don't know. So today we're actually going to cover ionic and covalent bonds, and I'm going to tell you guys a little analogy so that you can keep the two totally separate. All right, let's get into it. So first, let's determine where the elements that we're going to use, and let's determine where they're coming from, okay? We're going to be focused on elements from the first group. Keep in mind that a group is a column, okay? And the group tells you how many valence electrons an element has. And so the rows that go across, they're called periods, and the periods are responsible for telling you how many valence shells it is total. Okay, you might want to rewind the video so that you could wrap your head around what's going on. That's just a suggestion. If you ever sat to yourself and wondered why it's even called the periodic table, it's because it's organized in periods, period. So let's say we have an element, let's say sodium. Sodium is in the first group. So that means sodium has one valence electron. Let's take another element that we're all familiar with, chlorine. Chlorine is in the 17th, or this, in our case, the 7th group, because we're going to ignore the transition metals. All right, so chlorine is going to have 7 valence electrons. Now these two elements, they can't just exist how they are, because then they will be electrically unstable, because in order to complete what we call the octet, it has to be 8 total valence electrons in each outer shell. Now in order for sodium and chlorine to achieve this, the best thing and the most least energetic thing that could happen is that the chlorine atom could actually take away the 1 valence electron from the sodium. Now the result is that instead of 7 valence electrons, now chlorine has 8. And since it has 8, now it's electrically stable. However, since it has more electrons than protons now, that's going to cause the chlorine ion to be negatively charged. On the opposite hand, we have the sodium atom, whose electron was taken away. So now the sodium atom has more protons than it does electrons, and so it is positive. So now that the sodium ion is positive and the chlorine ion is negative, they can attract to each other like a magnet, okay? Because positive and negative, right? Opposites attract, right? Right? Just ask my ex. Nah, don't ask her that. She's cool, guys. But that does make me think of an analogy. An ionic bond, which is what I'm describing, an ionic bond is kind of like a bad relationship. It's kind of like someone coming saying, oh, I have 7 valence electrons and I just need 1 so I can be complete. I'm gonna just take yours. And it's a forceful type of relationship. Whereas covalent bonds, which I'm going to explain next, is more of a mutualistic type of relationship that says, okay, I have 4 valence electrons, you have 4 valence electrons, let's get together and then we can share, okay, sharing electrons. We can share and we can make something mutual. And the result of that sharing being 8 electrons. So I'll give you all an example of that too. So carbon has 4 outer electrons or valence electrons. So instead of using all of that energy to go and find 4 ionic bonds, no, it's not gonna do that, okay? Rather, it's gonna find elements such as another carbon, for example, that has 4, and those 2 proton nucleuses are going to actually share the 4 of each of those valence electrons to make 8 total and satisfy what we call that octet rule that I mentioned earlier. And that goes back to what I was saying when that's more of a mutual relationship. So the atoms can either take electrons or they can share. And so when they take and change the charge, that's called an ionic bond. And when they share, that's called a covalent bond. Let's look at the names. So it's called an ionic bond because when an atom changes a charge, now the name of it is an ion. And it's called a covalent bond because the word co, as in cooperate, it means to work together, and then valence means outer or outside. So now if you have a test and your teacher says, and this is going to be on, if you're one of my students and you're watching this, it's going to be on the next test, okay? If something says compare and contrast covalent and ionic bonds, now you're able to do that, okay? Sounds good? I already know it sounds good because I said it. All right, this is Professor McCullough, and y'all have a beautiful day. Make sure you like, you comment, and subscribe, and share the channel with anyone who you think might need help with like biology related things. All right, have a good one.